All right. Hello, everyone, and welcome to today's installment of the Corundum developer meeting. Thanks for tuning in. All right. Real quick agenda. We got announcements, project ideas, and then status updates. Announcements. The next Corundum developer meeting will be on November 6th at 9 a.m. Please note that time may change for you because there's a daylight savings time change on, I think, November the 5th here in the US. So it's going to be 1 hour later in UTC time. So you'll have to figure out in your local time zone if that changes anything or not. And then the next Switch developer meeting will be on October 30th. That one will be at the same time because, like I said, I think the time changes on November the 5th. Right. And again, I'm going to post, right before the meeting starts and whatnot on Zulip. So, pay attention there. If you're not sure, I'll post before it starts. So you don't need to join if you're off by an hour. All right. So product ideas, not going to go into this in too much detail, but here's a few things that you could potentially work on if you're interested in getting involved in Corundum and working on something. I've talked about these in previous meetings. Be happy to go into more detail about some of these, in the discussion if something looks interesting. All right, so moving on to status updates. There's a couple things that I want to talk about. I've been doing some more work on the PTP subsystem, and then I've also been thinking a bit about port splitting. So not only for the Switch, but also, we want to be able to test this and get this working on the NIC first. Basically, everything that's going to be involved in making that work, right? Where you take a 100 gig port, and you can run it as 100 gig, or you can split it and run it as 4 separate ports at a lower rate. So 25 gig, 10 gig, whatever. And then also a brief overview of some architectural changes. Might be some updates on that front. And then I've also been putting a bit of thought into a potential shared development test bed. So that's something I'd like to discuss. I don't know if people might have some ideas on how to put some of that together. So let's get into these one at a time. All right. So for the new PTP subsystem, I've talked about this for the last couple of meetings, but the idea is to distribute PTP time on the FPGA using a much more efficient setup where we basically have one wire that's providing the not only the time reference, but not only the timing reference edge, but also the PTP time itself, that will allow you to send that a long distance across the device without eating up a lot of logic resources. And then we'll have a hardware clock module, a PHC module, which generates this, and then leaf clocks, which will take the signal and regenerate the PTP clock that you want in the target clock domains with, all of the skew taken care of. And the idea is to also support using a truncated timestamp format from which the 96-bit timestamps can be reconstructed to reduce the logic resource utilization of all the components that are handling the timestamps, FIFO resources and whatnot. So at this point, I have the protocol that's actually going to be sent over the wire inside the FPGA more or less defined. I may need to make some modifications to that as things come together. We'll see. I have a simulation model that's mostly complete. There's still a few odds and ends that I haven't implemented yet. I have a leaf clock module mostly working in sim. There's a couple of odds and ends that I need to get hammered out on that. I need to put together the PHC hardware clock module. And once I have that working, then I should be able to test it in the hardware. So definitely let you guys know one way or the other how that works. Just for a brief overview of the protocol that I'm using internally. It's basically going to be a 16-bit UART-like protocol. So we have, if you know how UART works, the protocol that I'm going to use is 1 start bit, 16 data bits, and 0 stop bits, with the baud rate equal to the reference clock frequency. So it's basically a synchronous UART where we use the reference clock frequency as the bit clock. So that gives you 17 clock cycles for shifting in each byte of the reference clock for handling that. including potentially transferring that data through to a different clock domain. So this is something that you're going to have to do, or that's going to have to be done pretty commonly, because the leaf clocks are generally going to be running in, various, Ethernet TX and RX clock domains, or PCIe clock domain, or whatever. So having 17 clock cycles per 16-bit word to complete that CDC operation simplifies things quite a bit, right? We don't necessarily have to use a FIFO. We could use a much simpler kind of handshake synchronizer for that to work. Then the idea is to use an update period that's a nice even power of 2. So with 256 cycle update period, then we can fit 14 of these 16-bit words in each update message and still have all the framing work correctly, because we have 17 idle bits in between. So no matter where you might start, you're going to have enough idle bits to properly resynchronize. The format of the messages are going to be somewhat similar to how GPS Almanac works, among other things, where parts of the message are going to be the same and parts of the message are going to rotate out. So the idea here is that the information necessary to set the 64-bit clock are sent in every message, and then the other portion of the message cycles through information to set the 96-bit clock as well as the timestamp reconstruction. And the timestamp reconstruction, the idea is we're going to send information for 2 adjacent seconds, the current and the alternate offsets, which will provide a 500 millisecond reconstruction window, which should be able to handle, any kind of queuing delays and, skew compensation math and whatnot. That I think should work pretty well. But, we'll have to try it out in the hardware and make sure that it goes according to plan. All right, so moving on to port splitting. So the idea with port splitting is where you can take a 100 gig port that's made up of 4 separate 25 gig lanes and either use that as a single 100 gig port or as 4 25 gig ports. Obviously, it's one thing to, take that 100 gig port and only use the first lane as a single 25 gig port. It's still just one port, so it doesn't really change much about the design. The trick is, okay, if we want to run this as 4 different ports, we run them at 4 different rates, things might need to change for that to work. So the first aspect of this is clocking. So I've been taking a look at the CMAC documentation just to figure out what we might need to deal with here. So on the RX side, currently the CMAC RX streaming interface is set up to run in the same clock domain as the TX. But from looking at the documentation, it seems like you can either use the TX clock domain or the RX clock domain for that. Either of them should work. So if I switch that over to the RX recovered clock, then it will match what the 25 gig MAC would be set up as. So with that change, then you'd be able to effectively merge the CMAC and the 25 gig MAC together with just a couple of bit converters and muxes. So that's useful. Then on the TX side, the situation is a little bit more complicated because the CMAC needs all of the GTY transceiver channels to share the same TX clock. Right? So on the RX side, it actually has, I guess it has 10 inputs for potentially up to 10 channels for the RX recovered clocks. But on the TX side, it only seems like there's one clock domain. And if we want to be able to run the sub channels at different rates, like if we want to run a couple of them at 25 gig and a couple of them at 10 gig, we have to have separate clocking networks for TX for each channel. So I'm not 100% sure what's going to make the most sense for this. I did take a look at some of the clocking primitives. The buff GMUX primitives that are supported on the FPGA have 2 clock inputs, and you can select which one to use. But the only ones that can be driven directly by the GT cores are the buff G GTs, and those only have a single clock input. So if you wanted to switch the clocks on the sub channels between, synced to the first channel versus running separately, there doesn't seem to be an easy way to do that. But a possible alternative route is to run the channels with their own local clocks instead of running everything based off of the first channel. Um, and then add maybe a phase compensation FIFO to transfer the serializer data between the CMAC and the various channels. So this would then allow those clocks to vary a little bit in phase. So basically, instead of the CMAC driving the transceivers directly in 4 different clock domains or trying to get them all in the same clock domain, well, with a little bit of phase compensation, with completing a few steps to deal with a little phase offset, then this could potentially make things work in this mode. Flip side, it would add a small amount of latency, but I mean, for 100 gig, you're already adding a bunch of latency anyway in terms of the FEC and whatnot. So I don't think this would be really a major issue. But I think this would be a pretty straightforward change to make. So I'm going to take a look at that relatively soon and see if that's going to work. The other side then is the streaming interfaces, right? Because if we're going to take one port and split it into 4, how do we present that interface to Corundum and to the application section? And I can think of at least 4 options for doing this, and potentially there are some variations of these, and potentially there's something I haven't even thought of yet. Maybe somebody's got a better idea. So the ideas that I have so far, and each of these options has pros and cons, so I'm not sure necessarily what's going to make the most sense. So the first option is to have a single streaming interface, and the idea behind this is you just merge everything into a single streaming interface, and then you have asynchronous FIFOs connected to all of between this interface and all of the different Macs. So the problem with a single streaming interface is that you're going to have to deal with head-align blocking, and the way to work around that is to do interleaving of some sort. And it seems like that probably wouldn't be too bad, just to basically TDMA across the 4 sub-channels, but it does complicate things on the application level interfaces and potentially with some of the logic that might be handling things like I guess the pause frames and whatnot. If that's being done on the Corundum side of things, and it's interleaved, that could potentially require rewriting a few bits of code. But the advantage of this interface is that it's just a single port for everything, and potentially you can share all the logic. So yeah, I'm not 100% sure if that's the best option, but it's certainly an option worth considering. Second option that I was thinking of is a catenated interface, where in 100 gig mode, it acts as a single 512-bit interface. In split mode, it acts as 4 parallel 128-bit interfaces. And there's a couple of things that need to be sorted out here. One of them is sideband data in terms of timestamps and whatnot. I guess you'd also have to have 4 copies of all of that, which, is not necessarily great from a resource consumption perspective. And then on the ASIC interfaces, I'm not sure how that would work from a clocking perspective, because if you split each segment out and run that in a different clock domain, yeah, that could be tricky. Well, I mean, basically you would have to switch between running everything synchronous to the CMAC versus separate lanes. So you could do that with the buff GMUX things, but yeah, I don't think that one is super clean. I think the interface on like the MR Mac is something like that, where when you switch it to a lower rate, it's like running segments of the bus differently for the different channels. So there is some precedent for doing that, but I think just inside the fabric, it maybe doesn't make sense. The third option is to have separate interfaces, or separate streaming interfaces for the 100 gig Mac and for the 25 gig Macs. So basically you would have 5 interfaces, 1 512-bit and 4 either 64-bit or 128-bit. Problem with this is, I think, a lot of logic resource consumption, because you're either using one or the other, and the other set of logic that you have is just taking up space. And then we would also need to add probably a whole additional set of streaming interfaces to Corundum itself and to the application section and whatnot. One set for the 100 gig interface and one set for the split interfaces. So that could potentially complicate things, especially if, you need to handle data close to the max for, one mode or the other. So yeah, I don't know. The fourth option here is to do interfaces for each channel. So this is pretty similar to option 3, except you're basically going to merge the first Mac, the first 25 gig Mac with the CMAC. So you basically have a single 512-bit interface for 100 gig and for the first lane of 25 gig, and then you have 3 additional interfaces for the other 3 channels. And basically those 3 interfaces would only be used when you're in port split mode. Otherwise, it would just do everything on the first interface. So I think this one's a little bit better than option 3. But you still need to have an additional set of streaming interfaces. And then you also have this, weird factor of 3, which is not a nice power of 2. I'm not sure how that would change things. So, and another consideration as well that has been kind of at the back of my head for a while is frame preemption, which is something that's used in certain standards where you can basically have certain frames get sent in the middle of other frames over the link without, causing a frame to be dropped. It's kind of an interesting setup. I took a look at one of the Xilinx cores that support it, and that core uses basically 2 different streaming interfaces, one for the express traffic and another interface for the preemptible traffic. So if we're going to support that in Corundum at some point, that could be an argument maybe for doing everything interleaved on a single streaming interface, because potentially you could get similar behavior with interleaving without having to duplicate all of the interfaces. Not sure about that at this point, but it's definitely another important consideration. So I'm not sure if anybody has any other ideas in terms of how we might be able to do this, or any feel for, what might make more or less sense. But yeah, that's definitely another component that I'm trying to juggle here. So I'm thinking for the time being, what I might do is look into updating the wrapper to bring out all of the or to move the 25 gig max into the wrapper to support reconfiguring the transceivers and whatnot, and then bring out separate interfaces for everything. So probably something like option 3, where we would have a 512-bit interface for the CMAC and then 4 interfaces for the 25 gig max, and then we can adapt that to whatever is going to make the most sense for Corundum. And then we can figure out what that needs to look like maybe a little bit later, once we have a better feel for how all the pieces need to fit together. Right, so that about rounds that out. Now, just real quickly, in terms of some of the architectural changes that I've been thinking about, and this kind of dovetails with the port splitting. So the first thing is a single hardware interface. So currently Corundum supports multiple hardware interfaces, and this results in a lot of logic duplication. So I'm wondering if maybe it makes sense to move to a single interface. Obviously, there's a few changes that are going to be necessary for this to work. But especially in combination with port splitting, where you might have a lot of ports and potentially a variable number of ports, putting software in the driver's seat for configuring and managing all of the internal resources, I think is going to be a good direction to go in. And this means that we can also look at more expressive schedulers that will work across all the ports instead of having per port schedulers. Obviously, there are a few trade-offs associated with some of these modifications, but I think in general, moving towards more sharing in the hardware is going to be a good idea going forward. And I think potentially we'll still be able to support both. It just, if we move to single hardware interface by default, then then that's going to mean that we can make more trade-offs to improve performance while also potentially increasing the amount of area used by some of these components. If we don't need to worry about going, oh, this is going to be multiplied by 2 or 4 or whatever, depending on what board. So we might need to be more concerned about the logic, the area taken up by the logic. All right, so that's one thing that I'm thinking about doing. Also, switch integration. Carlos has been working on a packet switch version of Corundum. The idea is that we might be able to pull some of those pieces back into Corundum at some point. And when we do that, we're probably gonna have to make some changes for this to work properly. So one of them, that I've been talking about is, that I talked about just a couple minutes ago, is the switchable/splittable ports. How is that going to change like the application section interfaces and whatnot? If we pull in the packet switch components to have like an embedded switch, we might need to add additional interfaces to the application section for, internal switch ports, which I think could be quite useful for quite a few applications. Another aspect of this as well is the clocking, because the switch is probably going to run in its own clock domain. So it might make sense to decouple Corundum from the PCIe interface such that it can run synchronous with the switch. I'm not sure if this would change anything else in the application section or with those streaming interfaces, but that's definitely another set of considerations that I've been mulling over. All right. Now, one thing that we talked about last week, or 2 weeks ago, last meeting, in a little bit more detail, the application section passed through, where we'll have some provisions for adding more signals to the application block and passing those down through the hierarchy. And some folks from MLE were talking about what they've been doing kind of as an exploration on this to figure out what might make the most sense in terms of actually implementing this. And I don't know if they have any updates, but I also don't see any of the MLE guys on the call. So I guess there's not much else to say about this at the moment. They did present a couple of ideas last time in terms of using macros for this in a slightly cleaner way than what I was originally envisioning by including a couple of different files. So it seems like what we might be able to do is, actually, I don't think we need to include at all, but the idea is to define some of these things as macros, which can then be inserted into the module definitions and also the instantiations to facilitate this. And I guess one thing that I missed in this thing is we actually would need 3 different things. We need the module list, the module port list, instance port list, and then also a wire list when you're, working your way down the hierarchy to make the connections in between. And then potentially something similar can be done for parameters. So I think they came up with a pretty nice scheme to do this. I think it needs a little bit of refinement, but hopefully we'll be able to get that merged in relatively soon, so people can take advantage of that. Let's see. So that moves on to the final thing I wanted to talk about here is the potential shared development test bed. So I've had a couple people ask about, if I don't have access to FPGAs, how can I help work on Corundum? Obviously there's stuff you can do in simulation, but ultimately for doing any kind of fine performance tuning and whatnot, you got to work on hardware. That's really the only way to get the best feel for how everything's going to work. Simulation, you just can't really, it's good for, checking to make sure the behavior is correct, but for fine performance tuning, it doesn't really give you enough resolution, I suppose. So to have some sort of a test bed that people can connect to, well, we need, some host machines, we need some FPGAs, we need some stuff to interconnect things. And then we also need a way for, people to be able to log in and run stuff. So kind of 2 main aspects to this, right? One of them is the hardware. I have a few computers that could potentially be connected up to something like this. I also have a bunch of various NICs and PCIe form factor FPGA boards, and a bunch of ConnectX-5, ConnectX-6 NICs. I got Alveo boards. I got the whole bunch of stuff that we can load those machines up with. I also have two of the high-tech global HTG 9200 boards. So these are the ones that have 9 QSFP28s. So Carlos has been using one of these for the switch development. Potentially they could be used for other things as well, traffic generation perhaps. I don't know. I also have one of these network tester units. It's a unit called an ONT603. It's a 100 gig network tester that can generate traffic at 100 gig and also run a few tests and whatnot. So the idea is that, well, can we put all this stuff together in a way where it can be configured and used remotely and also potentially in a scriptable way, so you can run more complex tests without having to go through and reconfigure cables, reconfigure fibers and whatnot. So I've got a 32 port 100 gig packet switch. Well, it's actually on loan at the moment, but I do have one of those that could potentially be connected. What I've picked up more recently is a pair of 16 by 16 single mode optical switches. I actually have three, but one of them is a slightly different story. The two, I have a multi-mode one that needs work, and it's unclear how well that thing's going to work just in general. And then I have a pair of single mode switches. The single mode ones are more interesting because I have a whole pile of CWDM optical transceivers. So we can use these guys to hook everything up to these switches, and we can even potentially cross-connect the switches and use those to connect components in various combinations. So kind of what I was thinking we could do is get the two optical switches. We can get the two high-tech global HTG 9200 boards. One option, I suppose, is to basically connect one board to each switch. But what I'm thinking is going to make more sense is to basically put half the ports on each board on each switch. So we'd have like 4 ports to one board, 5 ports to the other board on each switch. And then you can use the switches to loop the ports back, or to hook the one board, or to hook the boards, cross connect the two boards, or you can connect them to other devices. So we can hook up several NICs, we can hook up several other FPGAs, we can hook up the network tester. So what I was thinking was we could put like one port of the network tester on each switch, and then we can cross connect the other 2 ports, or we can cross connect 2 ports on the switch. So we can take both network tester ports and run them to one switch and hook them up to one of the boards. It'd give us a lot of flexibility in terms of what can be connected to what. And with these switches, you can talk to them over the network and basically change the optical routing through them very easily. So you could write a Python script that talks to the switches, talks to the network tester, talks to FPGA boards, and runs a pretty complicated test setup. So seems like there's quite a few options on the hardware side. On the software side, that's a little bit less clear at the moment. One option, obviously, is just to install operating systems on all the machines locally, and then just people can log into them and hammer on stuff. But there's definitely some disadvantages with doing something like that in terms of, when you log into the machine, you don't know exactly how it's been set up previously. And that could potentially be a problem for certain things. So what I think would be a really cool setup is basically to set up all of the machines as diskless machines, net booted off of some sort of network attached storage, and then we can have a share for Vivado or whatever, so you don't have to install Vivado, but people can create their own images, basically install whatever operating system they want, boot that on the hosts, and then use that, and then every time you log in, you can load up your image, and you're up and running. So that gives you some isolation, right? You're not going to have a bunch of files and configuration from other users on there. It's going to be your own image. But the trick is, is there any kind of existing software that we could use for managing this sort of thing? Or is this, we're going to have to write some stuff custom? Not sure if anybody's familiar with anything along these lines, kind of on the slightly more systems administration side, but I'm definitely open to some ideas, because I think this could be a pretty useful setup, not just to provide access to people that, might want to get involved, but don't necessarily have access to much hardware, but also provide access to potentially a bigger test setup or, somewhat fancier equipment, such as the network tester and whatnot, and optical switches that folks might not have access to. So definitely something that's worth thinking about, that I would like to put together such that we'll be able to take advantage of it. At this point, I'll open it up for discussion. If people want to talk about any of this stuff, the floor is now available. Julian, you want to say something?
Yeah, it's very interesting. I will take things on reverse. I wanted to talk about the test bed
Sure.
first. It's an excellent idea. For the diskless hosts and all of that exists, and maybe we can set up a meeting later on I can explain all of that to you if you need to. For the
Well, so
diskless
I've done a
stuff.
couple things with diskless before, right?
Yeah.
But it's more of automating. How do we have something where somebody can log into some sort of an interface and say, hey, load up this image and boot this image? Or, I mean, I guess it wouldn't really be an image necessarily in this case, but like an NFS share for the root directory. So you'd have to have some way of somehow influencing the PXE configuration, so it's loading, your
Yeah.
root directory basically. Because I have a system at UCSD that's net booted, but there's only one root directory on all of the machines boot off of it. So that's
Yeah.
that's a partial solution, but the next level is, okay, how do we make this more flexible, such that you can basically have some sort of web interface or something to people can just set it up independently.
Yeah, I can send you some links about all of that,
Yeah.
because
Okay.
I'm working on a project which use that already.
Oh, okay.
So
Nice.
for testing,
Is there
for
kind
doing
of
tests.
an off-the-shelf open source package for that,
Yeah.
or you guys? Yeah.
Yes.
Oh, very
I
cool.
don't
Very cool.
remember the name right now, but I will find it and send it to you. Yeah, sure.
We've
Um,
used something similar called Ansible and also Puppet for automating Pixie deployment and data center. And
Hmm.
that's a very similar use case. You would just basically, instead of choosing a custom Pixie image for provisioning, you would just choose the Pixie image that would represent the environment.
Okay. Okay. Yeah, because I know I've heard of using, PXE NetBoot for installing an operating system directly, but that's not quite what we want to do here.
mm,
I have also there's Okay, so Ansible and Puppet, you
yeah.
said, okay, are worth looking into.
Oh.
All right. So
Ansible
I
and Puppet
was so
are some kind of management system that you can use then to apply some rules. I think that's what you said. That's how you use it, Joseph, right?
Yeah, so you would set up deployment rules for different environments, and then it would step through the deployment script for the system. But you would basically just stop it before it initially completely finishes and hands off the system, and you basically use it in the provisioning environment.
hmm.
Yeah. So it requires a little bit of setup first, and then it's very easy to change the image that you want to provision and all of that. But it needs quite
Correct.
a yeah.
You have to
You
set
need
it up first. It's a whole
you,
DevOps stack kind of deal.
yeah, exactly.
Right. Yeah. So there was one package that I was familiar with to some extent called Cobbler. Well, I haven't really used it, but it was installed on one of the clusters at UCSD, and that one I think is also for managing similar stuff in terms of it has like a web interface that you can have it re-image certain machines. So I guess that's kind of a similar idea, but that might be an older and maybe somewhat ad hoc solution versus some of the newer DevOps stuff. So yeah, definitely something worth talking about. And if we want to hold a separate meeting to talk about that, I'd be open to doing that. So yeah.
Yeah.
Was
And
there something else you wanted to discuss, Julian?
yeah, I wanted to add that here at my company, we've set up a lab with 3 machines, with 3 hosts. Each machine have an Alveo U50, and all these Alveo are linked with a switch, which is a MikroTik one with I think it's 40 gigs that can be used as a 4 times 10, and then each machine can be controlled, has an Ubuntu installed on this with Vivado. The USB cable are connected to the Alveo inside for reprogramming, and then you can also access the IPME console, so that you can reboot the machine if you crashed it. And all of that is accessible behind a VPN, and that can be, I don't know if it's the kind of stuff you might use, but anyway, it's available for use for other people if needed. It's some kind of lab that we set up for ourselves, but it has been done so it can be opened for external person as well. And we have
That
currently
sounds pretty cool.
we have some students who use them, students in FPGA and stuff, who use that for doing tests.
Gotcha.
Yeah.
Yeah, we should have a better setup, at least on Zulip for coordinating some of this stuff, or maybe not even on Zulip. I don't know. It depends on what makes
it depends.
sense. But yeah, so because yeah, if nobody knows about it, then nobody's even to ask for access to it, basically.
Sure.
But yeah, that does sound like a pretty nice setup that you guys have there.
Well, yeah, it was chosen to be not too expensive, to fit in the budget that we had, and it's used for my famous project on 5G and all of that.
Right.
But it can be used for other things as well, for study or for testing or for. We even plan to install some kind of automated testing for Corundum as well, like with
Okay.
CI at one time, because since we have 3 identical machines, we might be able to compile and do some automated tests.
Right. Yeah. I think there was that could be a pretty useful setup. Yeah, I think there was somebody who was working on that. That wasn't Carlos. That was I guess Antonio, who's hasn't joined the meeting in a while, but I think he was doing some work on some sort of automated testing as well. I can't remember exactly what that involved. I think it was partially Corundum and maybe also some switch related stuff as well. But yeah, there's definitely been a few people looking into doing stuff like that, and it would be nice to have a setup capable of doing some of that here, because I mean, one thing I have is I've got quite a wide variety of different boards. So
yeah,
it's
that's
obviously
the
it's one thing
advantage.
to have several identical boards, and I can certainly put Alveo U200s in most of the machines, but then also providing access to a variety of other boards that could potentially be useful. So yeah, depending on what people need, because obviously there are advantages and disadvantages to various boards. So
yeah, sure. We've took the direction of having only one kind of boards. But yes,
which is definitely a sensible direction if you're doing your own local internal setup. So
yeah, exactly.
Yeah, it's like on the couple of test beds that we have at UCSD, same kind of thing. They're all running the same board. I think we have like a set of the alpha data boards, ADM PCIe 9v3, and we also have a set of the Silicom Kintex ultrascale boards. So yeah, within those test setups, it's all, nice and regular. But yeah, one of the points of Corundum is that it can run across a lot of different boards, and well, that only works if I actually have boards to test on. Well, if I have more computers to put those boards in to do automated testing, that would be useful.
Yeah. And
on the switch side of the test. Oh, sorry. Go ahead.
Go ahead. You were first.
Just wondering on the testbed side, for the Arista switch, is that like an ONIC switch for configuration, or is it just planned to be like a single VLAN across all ports for the packet switch?
Well, I mean, I guess we could do multiple things on there. My thought is just kind of allow people to do whatever on the switch. So if you need a particular setup for a particular test, then you can do that, right? It wouldn't be like a management switch. It would just be for interconnecting the FPGAs and whatnot.
Okay.
So
I was just thinking for testing different link modes like bonding and stuff like that, you would have to configure on the switch side. So there'd have to be some interface for that configuration.
right. I mean, obviously you can just log into the switch command line and do stuff, but maybe there's other solutions that would allow you to access that in a more controlled way. I don't know. But yeah, the idea is that you should be able to configure the switch however you need for whatever test that you want to do. So that's different modes or bonding or whatever, then yeah. I think
Okay.
I
Yeah,
also
just another
have
thing to bring up.
another packet switch of some sort. I think it's one of those it's one of the white box switches. I'm drawing a blank on the name.
The Celestica,
yeah, one of the Celestica ones. Yeah.
Yeah.
I never quite got it actually forwarding data properly. I probably need to reinstall the OS on there and get it updated to the latest thing. Basically, I got it for relatively cheap. Realized it didn't support PTP. And then we're like, all right, well, I'm going to see if I can get an Arista switch. And then there was a really good deal on one of those. So now I have one of those too. So.
Makes sense. Yeah. So with that, you would be able to use ONIC, and it's basically like Docker for your switch configuration, and you can load different Docker images and all that.
Right. Yeah. So I think maybe what we could do potentially is, leave the Arista switch set up with its own, Arista CLI, because they actually have a nice interface on there and whatnot. And then for the other switch, I don't really care. We can put whatever on there. I mean, I guess I have the open source Sonic, but we could put something else on there. Or if your ONIC thing runs on top of Sonic, maybe. I don't know exactly. I don't know.
It's just the hardware shim for Sonic. Yeah.
Yeah. Okay. So yeah, we could certainly do something like that if that's something people want to experiment with. Because that seems to be the deal with the white box switches, is that since they don't ship with an operating system, you're kind of left to your own devices in terms of what to run on there. So yeah, so if we want to run something more scriptable and less, CLI where you can just log in and do stuff, then we could certainly do that. All right. Julian, was there something else that you wanted to talk about?
Yeah, I was wondering, speaking about multiple cards supported, do you know if you support some Kintex 7 based cards or not?
Kintex 7, not at the moment, because the PCI Express interface is totally different. So we'd have to write a new set of shims. There was somebody that was asking about that on GitHub a while ago, and it sounded like they got something working. But it seems like they didn't care to, contribute any code back upstream. So, like usual users taking and not giving back. So it's like, okay, I mean, it would be nice. It sounds like they got it working. It would be cool if they would contribute it back, but okay, well, whatever. So, Kintex 7 is also slow. It's hard to get stuff running even on Vertex 7 devices. So I haven't really had any particular motivation to do stuff with Kintex 7. And I don't have really much Kintex 7 hardware anyway. I guess I have a couple of the standard KC705 dev kits, so I could do something with those, but it's it's been a very, very low priority because it's enough stuff to do for the higher end stuff anyway. It's like, well, I might as well focus my time there.
Yeah, I was wondering that because I found some cheap FPGA based cards with some SFP ports.
Yeah, so it looks like there's a lot of reclaimed Intex 7 parts coming out of China. So I don't know where they're coming from, if there's some piece of equipment that's scrapped as e-waste and they yank all the FPGAs out of it and they're like, well, we can put this on a board and sell it. So,
I don't know, but I admit that as a personal user, it's kind of hard to spend a few $1,000 in a card.
well,
But
yeah, that's
if we
definitely
are
true. Yeah.
Yeah, so but if we are talking about a few $100, yeah, then yes, it becomes feasible. And so at least for the main principles, it should work. Of course, less um, the performance are not as big, but if it's just for experimentation and learning, it might be interesting. But
Well,
yes,
we
if
can
we
definitely
need
support it. It's more just a question of, how
time
many
and
resources we can put into
yeah,
doing that. So,
of
I mean,
course, of
it
course.
could be just an interesting project in general to work on that and make it work,
Sure.
right? Because you got to get the PCIe shim working. I mean, basically the sequence would go a bit like this. The first thing you do is you'd build the hard IP core model based on the documentation for the 7 series PCIe core, and then you'd build the shim, and then I guess a Corundum wrapper that includes that shim, and then you drop the top level design on there and hope that it closes timing.
Yeah, yeah, that's yeah, that's quite complex, but yeah, it would be nice if one day I could contribute to something like this. But
Yeah.
let's say maybe it's for later. I was just wondering.
Yeah, I mean, if you have the cycles, I'd be happy to,
Mm.
answer whatever questions you might have, if you want to go down that path. But yeah, it's definitely a something that would involve quite a bit of effort to get that
Yeah,
operational.
but for you, it's possible. It's
Yeah, there's
feasible.
no
There's
reason
no
it
big
wouldn't work.
blocker.
Yeah,
Yeah, okay.
yeah. Well, I mean, now that we have the PCI Express shim set up, then that makes it a lot easier because it's not like you got to write a whole DMA engine. You just got to write the shim that bridges the gap and takes the TLPs and whatever weird format they're presented in and repacks them into the
Okay.
generic TLP format. It's probably going to be, I think, similar to some of the Stratix 10 shims, but yeah.
Okay. Nice. Thank you.
And also, speaking of which, there are also some Aria 10 dev boards that are relatively reasonably priced as well. So it might be possible to take the Stratix 10 shim and make some modifications to it so it works on Aria 10 and then run Corundum on Aria 10. Some of those dev boards are only a couple $100. I have a couple of those actually. There's like 2 or 3 different dev boards that could potentially be interesting. I think the flip side is that it seems like the Xilinx tools are maybe a little bit easier to get access to than the Intel ones.
Yeah, it's what
So
I see also now. Uh, it happened that a long time ago, Vivado was very complex to get and to make work, and now you can download it and install it on your own machine, and it
yeah,
can create bits for nearly all FPGA, maybe not all, but most of them now, and for free.
yeah. Well, it's 7 series and newer, right? So if you have a 6 series part,
Yeah,
you're kind of screwed. But 7
yeah,
series
yeah,
and
yeah.
newer, you're fine. Yeah.
One problem I'm seeing with the Intel tools, especially, is on those Microsoft Catapult FPGAs, they don't include the part numbers for proprietary parts. So reverse engineering that kind of stuff can get a little complicated.
So I've got two different Microsoft Catapult boards, and from what I can tell, so one of them is an Area 10 based board, the other one is a Stratix 5 based board. And there's something wonky with the Stratix 5 based board in terms of the PCIe thing. So I don't know exactly what the deal is with that. It does accept the part number if you script the project creation or you change the part after creating the project. So it just doesn't appear on the list, but support is there. But using the second PCIe core on that is tricky. Right now you got to like LD preload something that somebody reverse engineered. Presumably there is some other way to turn that on, because I don't think Microsoft is LD preloading something. My guess is there's probably a line you got to put in a config file somewhere to turn that on. If somebody knows what that is, it would be great to know, so that maybe we could run something on that without having to LD preload something. For the Area 10 board, you drop the part number into the project and it works fine, as far as I can tell. So it is, yeah, it doesn't appear on the list, but you script the project creation and it works. So that's not really an issue from my point of view at the moment.
Well, that's good. Good that we're getting progress.
Yeah. Now I think there is another one that's starting to filter out, because I've seen a couple of them on eBay. That's a totally different board that has both an FPGA on it of some sort, as well as I think some sort of Broadcom SoC with ARM cores on it. And I don't know about that one. I mean, presumably it's a similar story where actually, so I think I did find a picture of the board that included the full part number of the FPGA. So potentially we could try just dropping that into Quartus and seeing if it accepts it. I haven't tried that yet, but that's potentially worth a shot. You don't need the board to know whether Quartus is like, oh, I don't know what part that is, or oh, okay, here I'll build you a bit file for that, or I guess not a bit file, but you know, the Intel equivalent SOF. Yeah. But yeah, it just, I think that the only one that's annoying at this point is the that Stratix 5 base board. The Area 10 ones, while they're less available, they seem to work pretty much okay out of the box. Again, I think the issue with that is more just getting access to the licensing and whatnot.
Yeah,
because
because if
all
you
those parts
cannot
are going to require
if
the
you cannot
license.
yeah if you cannot compile yourself the Corundum with the tools with Intel, because the tools from Intel are not free, right? Contrary to Vivado.
Well, I mean, technically Vivado is not free either.
Yeah, well, you can download it at least without, asking anything to anyone. I mean, you just fill the form and up you go. No? Then
Well,
you can use
right.
it,
So it's, yeah,
and then
it's
it's for the ultra scale stuff that you cannot compile without a specific license.
yeah, I'm trying to remember how it works on the Intel side of things, because they have like three different software packages, right? They have Quartus Prime Lite, Quartus Prime Pro, Quartus Prime Standard. I can't remember all the releases. One of them doesn't need a license. Quartus
Okay.
Prime Pro, I think, will build for, yeah. So you should be able to get Quartus Prime Pro without a license, without having to jump through any hoops, because I know you can build for the Cyclone 10 out of Quartus Prime Pro without a license. For all the other stuff, you need a license. So if you don't need a license for that, you should be able to download the software without a license. But if you don't have a license and you have an Area 10 board, then you're kind of hosed. So that doesn't really
Sure.
help.
I'm checking.
Yeah, I mean, it'd be nice if some of this stuff was more available. And I guess that would be another thing to sort out in terms of some sort of a test bed setup here is access to licenses and whatnot. Because we have a licensed server at UCSD that I can probably point people to for Vivado, but I don't think we currently have a similar setup for the Intel tools. We have some licenses, but I don't think we have a server set up for that. I guess that would be another thing to take a look at.
Yeah, the price of the cards are quite eclectic.
Well, which cards?
The IR10 boards based.
Oh, the
When
Array
you
10 ones?
yeah, when you look on eBay, for example,
Well,
it
which
can
board
be
are you looking for?
yeah. I don't. I'm more familiar with the Xilinx stuff, so I'm kind of looking, you know, just for checking a little bit how it works, because I'm not at all familiar with the Intel side of FPGAs. Maybe you are more than me, but
Right. So for the Array 10 boards, there's maybe 3 different boards that it makes sense to look at. Two of them are the Intel PAC cards. So PAC, I think, is Programmable Accelerator Card. So it
mm-hmm.
stands for. But if you search for Intel PAC, then you'll see those cards. They have 2 different cards with the Array 10 FPGA. So one of them is the Intel FPGA PAC with Array 10. Don't really have a more descriptive name for it or part numbers. It's possible it was like the first PAC card they released, so it's just a PAC card.
Okay.
And then they have their N3000 card. The N3000 one is, I think, a little bit more interesting, but I'm seeing a listing here. It was $225 for this thing. They only have one available. There was somebody who had a whole like pile of these things. Maybe it's this listing. Yeah, this guy has 50 of them for $245 each.
Yeah, that's quite
So that's not
interesting.
bad.
Right. That's not bad. Yeah, that's not bad.
Well, so the other
Okay.
thing about the N3000 cards is that they actually have a bunch of stuff on there aside from the FPGA. So they have an Array 10 FPGA, and then they have a PCIe switch. So I guess there's 16 lanes on the edge connector. The PCIe switch I think has 32 lanes internally. So there's 2 X8s to the FPGA. And then there's a little daughter card on there with 2 Intel NIC chips on there. And each of those gets another 8 lanes from the PCIe switch. And those are connected to the FPGA. And then the FPGA is connected out the door to the QSFP module. But there's a retimer chip in between the FPGA and the QSFP. That's an Intel retimer that is totally undocumented. So once I saw that, I'm like, shoot. So I don't know how to make that board work, because obviously you're gonna have to poke something on that retimer chip via I2C for it to work. So well, I don't know, maybe it works out of the box without any configuration, but most likely you're gonna have to poke something. But I think those boards are actually made by Silicom, and I think I might be able to get some documentation maybe, or some help from those guys. I haven't had the time to really dig into that. But yeah, I mean, it used to be these N3000 cards were like thousands of dollars, but if they're coming down to like $200, it's like, well, all right, maybe it's worth taking a look at that. If you can get a stack of those things, get Corundum running on the FPGA, could be interesting. But yeah, having the Intel NIC ASICs on there means you can do kind of bump in the wire type processing without needing any additional stuff. Yeah, so those are the 2 main cards I'm aware of from Intel. Oh, and then there's also the Hawkeye, I think, from Guidel. I have a whole stack of those that I best offered a while ago. Which it's also an ARIA 10 part. So there's a listing for $85. That might be for just one though. They have a few variations on those, it seems like. Another listing $150 for those things. So the Hawkeye board is like two 10G ports.
Yeah.
The that ARIA 10 pack board, the N3000, I think that supports, I don't know if it supports 100 gig, because I don't think the ARIA 10 has any 100 gig max on it, but it should support 25 gig, because I think it's one of the GT parts. So you can do 4x25 or something like that, or I guess you could do 100 gig soft Mac if you wanted to, potentially. So that one I think is a little bit more interesting in terms of supporting higher link rates. But the Hawkeye boards, they give you 2 SFP pluses. So
yeah, that's quite for experimentation. It's enough.
Yeah, definitely.
Just poke around and test some stuff at home. I mean,
yeah. I guess the one downside about some of these boards is that I guess both of these boards have that problem. Both the Hawkeye board and the N3000, they don't have onboard USB JTAG. So if you want to load it up, you have to use a separate JTAG cable. So I guess that's not really that big of a deal necessarily, but yeah, it's
you have
mean
to
if you want to do some work with that, you would either have to get a Intel JTAG cable, bit blast or whatever they call it, or a compatible cable to load stuff on there, which is not great, but considering the cost of the board,
that's feasible. I mean,
yeah, it's not the end of the world.
Okay, thanks.
Yeah, sure.
I will have a look for myself.
Was there anything else that you wanted to discuss? Sounded like there were a couple things you wanted to ask about, but maybe we've covered everything.
Not for now. I
okay,
mean, it's enough for today for me.
All right. Sounds good. All right. Anybody else that has anything they want to discuss? I guess we've lost pretty much everybody at this point, so everybody's had to drop off. Well.
Well, not from my side.
Well, yeah, you're still here.
Yeah.
But yeah, we went from 8 people down to 4. So all right, well, fair enough. It happens.
Yeah. Well, it's the evening here in Europe, so I think we are Carlos, we are on the same hour.
Yeah, I think so.
Yeah.
Yeah, you can see how the light is almost off. The sun is going down.
Yeah, that's the thing with Zoom calls. You never really know where people are calling from. Could be right next door, could be in a totally different time zone, halfway around the world.
Yeah.
All right. Well, I guess if we don't have anything else people want to talk about, then we can go ahead and adjourn for today, and then talk to you guys in a couple of weeks, or I guess next week if people care about the Switch. Carlos will be heading up the meeting next week, right?
Very interesting things coming on.
All right,
perfect. I will be there.
Well, looking forward to when you get that network tester. It'll be fun to play around with that and see what kind of fancy stuff you can do with it.
Yeah, right. I would like to have it now, but yeah.
Yeah. Well, I mean, one big advantage of the one that you're getting is you can actually plug QSFPs into it. The one that I have here is the CFP2, so that does complicate things a bit.
Yeah.
I have it simpler, yeah.
Anyway. All right. Well, I guess we'll adjourn for today and talk to you guys in a week or two, depending.
Okay, thank you, Alex.
Thank you very much.
Bye.
Sounds good. Talk to you.